All right, so a lot of this one is stuff that you should already know if you have not, and I understand that it was spring break, but if you've not been studying your rules, you need to get back on that. Okay, again, we just have a couple weeks before the exam. It's not next Monday, but the next. So I got it. Make sure that you know that. While you're taking your AP exams, because I know some of you have more than one, I'll record this, but that's why I wanted to give you all the packets, and I know they don't start till next week. I just don't know how long this will take. Whatever we get to next week when you guys start, I'll try to give that to you by Friday. So that way you'll have it and then you can watch the recording and do whatever you need to. My goal is to try to get through the packets that I gave you today before Friday. And then next week, just work free response and not a diagnostic test, but like a practice exam so you guys can see how much different it is. So I just want to make sure that you understand that I want to push to get through this. So a lot of this stuff is not very hard. Like I did and now I'm just copying them, but I know what I'm doing or whatever, but going through it, it did not take me long to do 15 through 18. So I'm hoping that we can get through it quick. But for the next couple of days, it's going to be bell to bell teaching. Does everybody understand that? Okay, so there's not going to be any time to do those practice problems in class. You're going to have to do them outside of class. If we run out of time, I will make recordings of those. I will give you the answers of the practice problems and stuff like that. If you have any questions, we can go over that as well. Now, I think, like I said, because we got 40,000 emails over break that you guys have a meeting during advisory today for AP. So y'all won't be with me during advisory, but next week during advisory, we could do that. If you guys have any questions and you want to come in during advisory and ask them, that's fine as well. So I got it. I have not done any of the practice problems for 15 through 18. I think that I have finished up 14. I can't remember. So I have to go back and look because I tried to take as much break as I could too. Okay. So just understand that. All right. Inverse trig functions. In this unit, you'll learn a broader set of integration. So we're going to talk about those inverse trig functions, and a lot of those are the ones once you do this, it's more proofs in this. So if you don't understand what's going on, it's not a big deal because it's trying to get you to those rules. So if you'll memorize the rules, you don't need to know the proof. Does everybody understand that? So that's the only reason it's trying to get you there. So suppose you have the equation sine y equals x. If you differentiate both sides with respect to x, you're going to get cosine y. So the differentiation of sine is cosine. Remember when we do y, we're going to do dy over dx. And then the differentiation of x is 1. So the derivatives. Derivative of sine is cosine. The reason we do dy over dx is because we took the derivative of y. And then the derivative of x is 1. All right, now divide both sides by cosine y. So we get dy over dx equals 1 over cosine y. And then it says because sine squared y plus cosine squared y equals 1, we can replace cosine y with. So if we solve for this cosine y, I'm going to do this up here so you can see it. You do not have to write this down if you don't want to, but if you do, that's fine. I'm going to solve for just cosine. So I'm going to subtract sine squared y. And then to get rid of the square, I'm going to take the square root. So cosine y equals the square root of 1 minus sine squared y. So I wanted you to know where that came from. So then we're going to replace it. Dy over dx equals 1 over the square root of 1 minus sine squared y. And then because from the very beginning, our initial problem, sine y equals x, you can replace sine y with x, and the derivative equals 1 over the square root of 1 minus x squared. It says, now go back to the original equation where sine y is equal to x and solve for y in terms of x. So y equals sine inverse x. If you differentiate both sides with respect to x, so if we differentiate y, we're going to get dy over dx. We're going to differentiate sine inverse of x. We're going to replace dy over dx, and you get the final result. So this is your rule that you'll have in your first column, like on that first page of your cheat sheet or whatever. So it'll say the derivative of sine inverse x. What was our derivative? It was 1 over the square root of 1 minus x squared. So again, it's just a proof. The next rules or all of the rules are in that next box. So if those are not in your book, you need to memorize those too. I can't remember if they're in the front or not. I think they are. So there are all your rules. Make sure you reference back to them. So notice the domain restrictions for inverse sine, cosine, secant, and cosecant. So again, these have domain restrictions. So it has to be greater than 1, between -1 and 1. And again, remember why does cosine and sine have to be between -1 and 1? Why does that have to be between? Where does it fluctuate? From -1 to 1. And the inverse is going to flip it upside down. I mean, not, normally a sine curve is horizontal. The inverse is going to flip it vertical. So it's going to be between that -1 and 1 on the x-axis. So that's why it's -1 to 1. Why are these this way the same exact way? So you got to keep them positive because they're above the x-axis. Example, first one, d over dx, or the derivative sine inverse x squared. So if we look up here at the rules, it says to do 1 over, you guys did, so like if you see this one, u prime over the square root of 1 minus u squared. So we have done these. So this one writes a little bit different. So when you're looking at this, the next one would be u prime over 1 plus u squared. This is how our book shows it and how we've been doing it the whole semester. This one is u prime over absolute value of u, square root of u squared minus 1. Excuse me. Negative u prime over the square root of 1 minus u squared. Negative u prime over 1 plus u squared. And negative u prime over the absolute value of u, square root of u squared minus 1. So in our first example, what is our u? You don't have to write that. You probably already know that. Follow the rule. So our sine inverse is this one up here. What's the derivative of u? Over the square root of 1 minus, what was our u? What is x squared squared? So 1 minus x to the 4th. All right, so try to get the tan rule and the problem. What's our u for example 2? 5x. Our rule says u prime over 1 plus u squared. So what's your u prime? Over 1 plus u is 5x squared. Square 5x and you get, say it again. 5 squared is 25x squared. It's okay. It's okay. All right, same thing on the next one. Your secant rule is at the very top, trying to get them both there at the same time. What is your U? So it says U prime on the top. What's your U prime? Over the absolute value of U. And then underneath U squared. So it looks like this. And then you'll want to square that out. I'm not going to make you see all that work. You should be able to do that. Me too. X to the fourth minus 2x to the third plus x squared minus 1. When you multiply this out, you get x to the fourth minus 2x cubed plus x squared. And then we have the minus 1 on the end. Then they show you the integration of those. So it's just the reverse. If we have the integration of 1 over the square root of 1 minus u squared, it's sine inverse. 1 plus u squared is tan inverse, and u square root of u squared minus 1 is secant inverse. So we'll get your examples. The integration x dx over square root of 1 minus x to the fourth. So which one is this one going to be? It's got to be sine, right? All right. So don't forget about u substitution, and we're going to let u equal x squared. I don't have enough room in here to squeeze it in where you can read it. Du is going to equal what? If I take the derivative of this, I'm going to get 2x, and then remember we write dx. So to get it to just be x dx, what do I have to do? So 1/2 du is going to equal x dx. We divide by 2. We're going to pull that 1/2 out of the integration. You guys know that that's what we do. That's going to leave us with that du, the square root of 1 minus u squared. Now let me go back. Does everybody understand why u equals x squared? Yes or no? So some of you are looking weird. It's u squared. So what's the square root of x to the fourth? X squared. That's where that's coming from. So if you didn't know, that's where it's coming from. All right. Our rule says we can pull that 1/2 out. The derivative of 1 over the square root of 1 minus u squared is sine inverse u plus c. And then what was our u? So 1/2 sine inverse of x squared plus c. Please don't forget to put your plus c's when you're doing integration. What would the next one be? Also going to be what? It's also going to be sine. What's weird about it though? It's got a 4. So we got to figure out how to fix that 4. So I'm just going to rewrite the problem down here for just a second. Dx over the square root of 4 minus x squared. Our problem is the 4, so we're going to factor that 4 out. Bless you. Bless you. When I factor out the 4, I'm going to get 1. And then what did I do? How did I get 1? Essentially, what did I do to get 1? I divided it. So that's what I'm going to do to the x squared as well. So I did 4 divided by 4 to get 1. And I'm going to do x squared divided by 4. Now, because I have this perfect square underneath, I can take that thing out. And it'll look like this. 2 times the square root of 1 minus x squared over 4. And then I can pull that 2 out completely. But remember, it's on the bottom, so I'm pulling out a 1/2. So 1/2 integration of dx over the square root of 1 minus x squared over 4. We're going to continue this problem on the next page. I'm going to rewrite this on the top so you guys can see it. Everybody got this one? All right, so I'm going to rewrite it just a little bit different. You said that it was going to be sine, but if it's going to be sine, I got to have a u squared. So what is my u going to be? If this is where we're at right here, what is my u going to be? Say it again. X over 2. Take the square root of both. Everybody understand that? So I'm going to rewrite this as 1 minus x over 2 squared. Does everybody understand? All right. So now what's our u? X over 2. What is the derivative? What's the derivative of x over 2? It's 1/2. Don't forget to put your dx. How do I get dx by itself? Because I just need dx. Multiply by 2. So 2 du equals dx. And then we're going to substitute. So on the outside, we have 1/2. We're doing the integration of dx over the square root of 1 minus x over 2 squared. This is just me rewriting the problem. We're going to change it to terms of u. So 2 du over the square root of 1 minus u squared. Now what can I do? Do what? I can pull that 2 out, but what's it going to do? It's just going to cancel it anyway. So we're going to mark it out. What's the integration of du over the square root of 1 minus u squared? Sine inverse of u plus c. And then we substitute that u back in and we get what? What was our u? And that's it. So if you get something that looks a little bit weird, just factor it out. But it should come out perfect. Okay. Look at your next example. What's your u on this one? So we can rewrite it like this. So what is our u again? d dx. What's our derivative of that? Same thing. The only way it'd be any different is if we have something up there with the x, so like a 2x or whatever, and then we'd have to multiply it by 2. That is the same thing that we have on top. So this is a normal problem. We don't have to divide, multiply. We don't have to do anything crazy. So this now turns into du over 1 plus u squared, which is tan inverse. And then plug back in. What was our u? That's it. All right, let's do one last type that's slightly more difficult. For this one, you need to remember how to complete the square. So we need to put it in terms of the square. So like this one is 1 plus, so that's a perfect square plus perfect square. Does everybody understand that? This one is not, so we need to do that. So remember how we do that. We move that last number over and we put blanks in. We take that middle number divide it by 2, and square it. And that will go in both blanks. So what's 4 divided by 2? Square this. This side should be a perfect square. What are your factors of 4 that add to 4? 2 and 2, right? So we can rewrite this side as x plus 2 squared. And then we get a -1. We're going to add the 1 over. Typically, you like to put it in the back, but we're going to put it in the front. And the reason that we're going to do that, if we look at all of our things, where's our 1? Except for this one, but we don't have a square root, right? So the only one that we have without a square root has the 1 in front plus u squared. So I'm going to write it like that. If you put the 1 in the back, it's perfectly fine. There's nothing wrong with that. It's just not going to look like the rule. So as long as you can see it, it's perfectly fine how you write it. So we're going to change it up to be 1 plus x plus 2 squared. So then we can rewrite the integral as dx over 1 plus x plus 2 squared. So now what is your u? So what is du? Just dx, right? 1 dx. That's what we have on the top, so we're good to go. So we're doing du over 1 plus u squared. And which rule was that? It was 10. And then on the next page, it says plug that u back in. So we'll rewrite it on the next page. What is your u? X plus 2. So on the next page, tan inverse. Instead of u, we have x plus 2 plus c. Evaluating these integrals involves looking for a particular pattern. If it's there, all you have to do is use algebra and use substitution. The integrals will show up again when we do partial fractions. Otherwise, as fat as the AP exam is, it should say it's 4. Oh, it says 4. It looks like fat from up here. This is all you need to know. Sorry, y'all. Try these solved problems and don't forget to look for those patterns. Get your index card and cover the answers. We don't have to do that because I already did. So find the derivative of sine inverse x over 2. So the rule, because it's over on the other page and I'm sure you haven't memorized it, is the integral or the derivative of sine inverse u or we wrote it as u prime over the square root of 1 minus u squared, whichever one that you want. All right, so what's our u prime going to be? One half over the square root of 1 minus, what was our u? X over 2 squared. We're going to rewrite it. 1/2 over the square root of 1 minus x squared over 4. You see that this is a problem that we already did. Okay, so it's just going backwards with it. So then on the bottom, I need a common denominator. What's my common denominator going to be? 4. So it'll be 4 over 4 minus x squared over 4. I can factor out a 1/4, which will leave me with 4 minus x squared. So I factored out that denominator. What is the square root of 1 over 4? What's the square root of 1? What's the square root of 1? Square root of 4 is 2. Remember fractions, you just take the square root of the top and the bottom. So we're gonna have 1/2 square root of 4 minus x squared. What do you notice happens? Your 1/2 cancels out, you're left with 1 over the square root of 4 minus x squared. So that's taking that other problem backwards. What about the next one? What's the difference in this one and the other one? This one looks like the other one we did, right? What does it not have? The square root. So this one is not, it's not sine, it's gonna be what? Tangent. Tangent's the only one without square root. Is everybody good? You do the same work because you've got to get it into a U and a 1, right? All right, so how do I get this into that? Okay. We're going to divide it by 4. If you don't like looking at it like that, we factored out the 4. It's the same thing. It's whatever you want to do. Here, if you're doing this, you're factoring out the 1/4. You still get the same thing. It's not a big deal. Over here, we can take out that 1/4 now, and we get the integration of dx over 1 plus x squared over 4. All right, we're going to rewrite it. Your 1/4 is going to go on the outside. 1 over 1 plus, what's your u going to be? X over 2. Take the square root of both squared dx. Flip your page. Just going to keep going with this problem. It just breaks it down. What'd you say your u was going to be? X over 2. So that's what we're putting over here. So that means du is going to be 1/2 dx, which means, what do we have to do? So 2 du equals dx. So now we have 1/4. What do we do with this 2? Put it on the top. 1 plus u squared du. Now what can I do with that 2? Yeah, they can reduce. Remember, I can pull that 2 out, or you can go ahead and reduce them now. So that way you're not writing a separate line for that. It's up to you, whatever you want to do. Which means we have 1/2 times the integration of 1 over 1 plus u squared du. Which integration rule is this? So we're going to have the 1/2. It is tan inverse u plus c. What was our u? And that's it. What's wrong with problem 3? Yeah, I have to complete the square. I don't have that perfect square underneath, so I need to fix that. So we have negative x squared plus 4x minus 3. I like my x squareds to be positive, so I'm going to move those over. So I'm going to have a positive x squared, a minus 4x. I'm going to put my blank, which means I left negative 3. Does everybody understand that? I moved it the other way. All right, what goes in the blank? How do I find that blank? 4 divided by 2 squared. Doesn't matter what sign you use because when I square it, it's going to become positive anyway. So just use the regular number. 4 divided by 2 is 2. Squared is 4. What I do to one side, I have to do to the other. The only time that negative is going to matter is right here. When I rewrite it, I'm going to have an x minus 2 squared. And then on the other side, excuse me, I'm going to have a 1. All of our square terms like this, our u squares are in the back. So I'm going to move it to the back behind 1. So everybody understand that the 1 always comes first and then the other one. So we're going to change it into 1 minus x minus 2 squared. We're going to rewrite the integral into 1 over the square root, and we're going to put this underneath 1 minus x minus 2 squared. What is our u going to be? So what's our du going to be? 1 dx or just dx. So I don't have to do anything. That means I don't have to divide, multiply, pull anything out. It's good to go. So I can just rewrite it as 1 over the square root of 1 minus u squared du. Which integration is this? Sine inverse. So we're going to do sine inverse of u plus c. And then what was our u? So again, as long as you know the rules, you should be okay. We're at a practice set. We're going to skip over that. Go down to the bottom where there's a box. We are not playing today yet. So there's a possibility it could be made that Ronnie makes for playing today. Bring anything. All right, the integration of du over u. We had u prime over u. And that was ln absolute value of u plus c. You guys already knew this because we had the integration of 1 over x was ln x plus c. So you've seen this. This is not new either. Again, all those rules that you should start studying again. All right. Notice the absolute value in the logarithm. This ensures that you aren't taking the log of a negative number. We can't take the log of a negative number, so that's why they leave it as absolute value. If you know that the term you're taking the log is positive, for example, x squared plus 1, we can dispense with the absolute value marks. Let's do some examples. So whenever an integrand contains a fraction, check to see if the integral is a logarithm. Usually the process involves u substitution. So when we look at this, what can we do before we even start? Take the 5 out. So we're going to have 5 times the integration. Of dx over x plus 3. So then what would our u be? So then what would du be? 1 dx, which is already up there. So that means we don't have to do any work to fix this. So what we have is the integration of 1 over u du. When we integrate that, the 5 goes out front. What is the integration of 1 over u? ln absolute value of u plus c. And then when we plug back in for that u, we get 5 ln. What was our u? Absolute value of x plus 3 plus c. right? So in example 9, what do we need to check? That our bottom does what? Makes the top. Does everybody understand that? Can we do anything with this? We could pull the 2 out, but it's going to screw us up. Why would it screw us up? What's the derivative of the bottom? Everybody see that? So be careful if you have a function up there, you don't want to pull that 2 out. Look at it first. So our u is going to be the x squared plus 1, and our du is going to be 2x dx, which turns this integration into 1 over u du. So it's a real simple one. 1 over u du is ln absolute value of u plus c. And what was our u? And that's it. More integrals of trig functions. So the first one that we have is integration of tan x. And remember, I told you a lot of these are just doing proofs to how you get to them. So you don't necessarily have to know. If you were doing this in the multiple choice, you memorize the thing, go on. But if you don't, try to get to it. How do you get to it? How can I rewrite tan? Sine over cosine. We're going to flip our page. What can we let u equal? We had the integration of sine over cosine. Why would we make it cosine? Is sine. So what does that turn it into? The integration of what? Whenever you do u, right? So we used u as cosine, that was on the bottom. So we're going to put our u on the bottom. And then what did we get when we took the derivative? 1 du. So that's why it goes on the top, because it matches the top. Is everybody good? All right. So then, hold on a minute. What's this? It's negative. Yeah. So sorry about that. So this one's going to be a negative 1 over u du. What can I do with that negative? Pull it out so it doesn't really matter in the problem. And then I get negative. What's 1 over u du? Ln absolute value of u plus c. And what was u? And that's it. So what is the integration of tan? Negative ln absolute value of cosine x plus c. But again, if you forget it, you can make it. All right. What about cotan? How can I rewrite it? What would our u be? So du would be cosine x dx, which changes our integration into the integration of 1 over u du. So we have ln absolute value of u plus c. Plug it back in. Ln our u is sine x plus c. All right. Therefore, the integration of cotan x dx is ln absolute value of sine x plus c. How do I rewrite secant? I'm going to go ahead and flip our page after that. However, if you try u substitution at this point, it won't work. So what should you do? You should learn this one. It's what you should do. Does everybody understand that? This is one of those that would be really hard to memorize. You multiply the secant x by secant x plus tan x. This gives you this integration right here. When I distribute the secant, On the top, you have secant squared x plus tan x secant x, or secant x tan x. It doesn't matter which order you put it in. Over secant x plus tan x. Then you can do u substitution. Our u is going to be the bottom. The reason it's going to be the bottom is because when you take the derivative, what's the derivative of secant? What's the derivative of tan? Which is the top. Does everybody see it? I just wrote these two backwards. It's still the same thing. So then it turns it into 1 over u du, which is ln absolute value of u plus c. And then our u was secant x plus tan x plus c. So the integration of secant x dx is ln secant x plus tan x plus c. We're going to do the same thing on the next one. So we're going to multiply it by cosecant x plus cotan x. That gives us the integration of cosecant squared x plus cosecant x cotan x over cosecant x plus cotan x dx. If we let the bottom be u and we take the derivative, the only problem is we have two negatives. So what do we need to do? Pull out a negative. So this is going to be negative 1 over u du. You can put the negative 1 in the front. I don't care how you do it. It's up to you how you write it. And we're going to integrate that. So we get negative ln absolute value of cosecant x plus cotan x plus c. You're going to rewrite that in the next box. Again, it's probably much easier to memorize these than to have to derive them. It's very good. Again, rewrite it in the next box. Negative ln absolute value of cosecant x plus cotan x plus c. As we do more integrals, the natural log will turn up over and over. It's important that you get good at recognizing when integrating requires the use of a natural log. All right. Let's learn how to find the integration of e to the x. Remember that the derivative of e to the x is e to the x. You should be able to predict the following formula. So if it's the integration of e to the u du, it is the same thing plus c. All right, on example 14, what is our u? What is our du? 7 dx. The problem is we don't have a 7, so what do I need to do? So we're going to rewrite this as the integration of e to the u du over 7. What can I do now? Take the 1/7 out, the integration of e to the u du. What is the integration of e to the u du? E to the u plus c. Substitute it back in. What was u? So we get e to the 7x over 7 plus c. If you leave it as 1/7 e 7x, that's fine. Don't stress out about that. All right. In fact, whenever you see e to the kx dx, your integral is going to be 1 over k e to the kx plus c Or like we did, so that's this part, that's what that looks like. And then we put it back together, so it would be e to the kx over k plus e. That's this one. Doesn't matter how you write it. What are we going to use for u on this one? Du is? Okay, what do we have? So what do we need to do? Divide by 6. So we get the integration of e to the u du over 6. We can take the 1/6 out. And then we're going to get 1/6. The integration of e to the u is e to the u plus c. And then we can put the u back in there and the e on top of the 6. So e, our u was 3x squared plus 1 over 6 plus c. Again, you can keep the 1/6 out. That's not a problem. Whatever you like is fine. It's going to be the right answer. All right. What about the next one? What are we going to use? U is going to be, du is going to be cosine x. That's what we have, so we don't have to do any work. So this is the same thing as the integration of e to the u du, which is e to the u plus c. And what was our u? So e to the sine x plus c. All right, without going through all of that other stuff right here at the bottom, you can read over that whenever you want to. We're going to have another integration rule. And again, you should know this. If we have a to the u, it's 1 over ln a times a to the u plus c. To remind you of the rule. Again, you don't have to write it down. It's right there, but if you want to. So 1 over ln a times a to the u is the rule. So we have 5 to the x. So we're going to use ln of whatever your base number is, which is 5. So this would be 1 over ln 5 times. And then a to the u is exactly what we have. So 5x, 5 to the x. And then we put a plus c. If you want to put them together, you can, where it's 5x over ln 5, perfectly fine. All right, so try the next one. Try the next one. What can we do on this thing? Don't even think about this, because remember, this is a number to a power of x. This is not the same. So tell me what you would do to integrate this. Pull out what? A 1/3. So we're going to have 1/3 the integration. What will that leave me with? Or 1 over x dx, so you can see it a little bit better. Now I can integrate. And how am I going to integrate it? What is the integration of 1 over x? ln absolute value of x plus c. I didn't have to use the u. Understand just really quickly, if you did use the u, what would be your u? (3x). If you don't pull the 3 out, just like we did on the other one where we had the 2x on top and I told you you didn't have to pull it out. What would be your du? And what would I have to do? So the 1/3 will still be there. So you can't really mess it up. Does everybody understand that? All right, look at your next one. What about this one? Which one is your u? Why is the bottom your u? When you take the derivative, it's the top. So u is x to the third minus 1. Du is 3x squared dx, which is what we have. Which puts us with the integration of 1 over u du, which is ln absolute value of u plus c. What was our u? There you go. Everybody good? How do I do the next one? What do I have here? See it as e to the u du, right? So what do I need? What do I need to check every time? U and du, right? So what would your u be? What's du? Do I have a 5 in this problem? Do I have a 5 dx? So what do I need to do? So I'm going to get the integration of e to the u times du over 5. Or what do I need to do? Apply to 1/5 e to the u du. What is the integration of e to the u? Itself. And what was our u? What's the difference in the next problem compared to this one? The constant is the base, so it's the 1 over ln a times a to the u. What do I need to make sure of? The u. Always make sure of that u. So what is your u? What's your du? 3. Is that okay? No, I don't have a 3 in here, so what do I need to do? Which means I'm pulling out of what? Which means I'm going to have 1/3 times. What am I going to have? 1 over ln 2 times. Yep, 2 to the 3x. We're going to put it together. On the top, you do have your plus c, but we're not worried about that yet. Only thing I have on the top is 2 to the 3x. On the bottom, I have 3 ln 2. Tell me what your log rules say about a number in front. It can become the what? Exponent or the power, yep. So we're going to change it to 2 to the 3x over ln 2 to the third. We can clean that up a little bit more. What is 2 to the third? So don't be freaked out if you don't see the answer at first. You might have to do a little bit more work to get there. Don't forget those rules. And then that brings us to practice problems again. Go to 16. Is one of the last things that we did. It's the area between the two curves where we talked about top and bottom curves and then left and right. That's what we're going to go over. So suppose you wanted to find the area between the curve of y equals x and y equals x squared from x equals 2 to x equals 4. Remember, we talk about the one that's on top first, and then we talk about the bottom. So which one is on top? X squared, which one is on the bottom? And we subtract those. So that's where they get this integration from right here. Where did the 2 and 4 come from? Because that's where they bound it, 2 and 4. Is everybody okay with that? All right. So then it says evaluate it. So how do we evaluate it? What is your integration of x squared? Integration of x. And then we're going from 2 to 4. How do I do that? Plug in which one first? The top first and then the bottom. So 4 cubed over 3 minus 4 squared over 2 minus, then we're going to plug in 2 cubed over 3 minus 2 squared over 2. And to save us time, if you're okay with it, I'm just going to write the answers. 38 over 3. You can do decimals, it's fine. Not a big deal. Everybody good? All right. So if a region is bounded by f of x above and g of x below at all points of the interval a to b, then the area of the region is given by. So what this sentence says, remember, if they cross each other, so it's like a helix kind of deal, then you have to change it up. You have to add the other one, right? Does everybody remember that? So like right now, it looks just like this. So we're going from here to here. If at some point between there, they cross, you have to add these two up. So this one is just saying, if they look like this, one is on the top, one is on the bottom, there's no intersection of the two. Then you're just going to do the top minus the bottom integration, evaluated from A to B. All right, so then on the next one, it says find the area of the region bounded by the parabola y equals 1 minus x squared and the line y equals 1 minus x. But the problem is they don't give us any boundary lines. So like from where to where? How do we figure that out? How did we figure out, or how could we figure out? Let's go back to this one. How could we figure out that 2 to 4? Wherever they what? Cross. It's wherever they cross. So remember that. Where they cross, they are equal. So anytime we're going to find those points of intersection, so we're going to do 1 minus x squared set equal to 1 minus x. So anytime they don't give you boundaries, you have to find your own. I'm going to move the x squared and the 1 over because I always want my highest power to be positive. So I'm going to add my x squared. When I subtract my 1, I get 0, and then there's a negative x on the other side. How do I solve this? Say it again. Pull out an x. And then my two answers are 0 and 1. Sorry, y'all. So it just tells you the left is 0 and the right is 1. We're going from 0 to 1. Flip your paper. As you flip your paper, look at mine. Which one is on top and which one is on the bottom? 1 minus x squared is on the top. So we're going to do the integration from 0 to 1. Which one did you say was on the top? Minus. The one on the bottom was 1 minus x dx. We're going to clean this up, distributing our negative. So we're going to have a negative x squared. I just pulled this one first. My x term, negative makes a positive x. And then 1 minus 1 is going to be 0. So this is what we're actually deriving. I'm not, sorry, integrating. What's our integration of x squared or even negative x squared? And then your x. Sorry, it should be minus. And then we're going from 0 to 1. What do we do now? Do we have to plug in 0? Why? It's just going to make zeros anyway, so you don't have to do that. So we're only going to plug in a negative 1 cubed over 3. Watch that, do 1 cubed, and then the negative. On this one, it wouldn't matter, but on an x squared, it would. 1 squared over 2. And I'll go ahead and tell you that that gives you 1 over 6. All right, so sometimes you're given the endpoints and sometimes you have to find them on their own. So look at this next one. Find the area of the region between the curve y equals sine x and y equals cosine x from 0 to 2 pi. So what happens here from 0 to 2 pi? They cross each other. So we have to add both of those together. So two different integrals added together. Your first integral is going to go from where to where? 0 to pi over 4. Plus your second integral is going to go from pi over 4 to pi over 2. What's going to be the first one from 0 to pi over 4? Cosine x, because it's on the top, minus sine x. And then, everybody understand that? That's where we're at. So on this very first one, it says in the first region. So we're only talking about the first region. You told me it went from 0 to pi over 4. And that cosine was on top of sine. That's all we're writing on this first part. Then it says the second region. So when we flip our page, you can go ahead and flip your page. The second region went from where to where? Pi over 4 to pi over 2. And what are we going to put first? Sine x minus cosine x. So again, pi over 4 to pi over 2, but this time we're doing sine on top minus cosine is on the bottom. We have to add those two together. So our first one was 0 pi over 4 cosine x minus sine x dx. Then we're going to add the one that we just wrote, pi over 4 to pi over 2 of sine x minus cosine x dx. So you're either going to use your unit circle or you're going to use your calculator. So everybody understand that? Unit circle or calculator. You need to memorize that unit circle. It makes it much easier. The major points on the unit circle are what you're going to get on the test. They're not going to give you anything weird on the calculator inactive. So everybody understand that? So it's all like a memorization thing. I'm going to go ahead and tell you that when you evaluate this one, you get square root of 2 minus 1. When you evaluate this one, you get square root of 2 minus 1. Square root of 2 plus the square root of 2 is 2 square roots of 2. Negative 1 plus negative 1 is, what's it? Right. So then it talks about horizontal and how it changes. So you can go ahead and flip. Horizontal, they just identify C to D. It's the same thing, A to B, whatever. Your littlest one goes on the bottom, your big one goes on top. Right here, it says f of y. I apologize, y'all. It's on the right, and g of y is on the left. So remember, we did top because it's bigger values than on the bottom are smaller values. If we're doing left to right, right are the bigger values, left are the smaller values. So f of y minus g of y. Same exact thing. Right. So check this one out. Here's your function. It says from 0 to 3. Which one is on the right and which one is on the left? Y plus 6 is on the right. This one is on the left. So when you slice the arrow horizontally, the right end of the section is the curve y plus 6, and the left is y squared. We're going from 0 to 3 of y plus 6 minus y squared dy. I'm so sorry, y'all. We're going to integrate it. What are we going to get? Y squared over 2 plus minus from 0 to 3. And you're going to get 27 over 2. Which one do I have to plug in? Just your 3. Why do I not have to plug in 0? It's going to make everything 0. Everybody good? Find the area between the curve square root of x plus 3 and the square root of 3 minus x on the x-axis from -3 to 3. So from -3 to 0, if you slice the region vertically, the curve y equals square root of x plus 3 is on top and the x-axis is on the bottom. From x equals 0 to x equals 3, the curve y equals square root of 3 minus x is on top and the x-axis on the bottom. Therefore, you can find the area by evaluating 2 integrals. Guys, this is how you know these x's, and if it's y equals, how you know which one you're doing. So this one's going to be the vertical normal top and bottom. Does everybody understand that? So if your boundaries are left to right, you're taking a top to bottom. If your boundary is bottom and top, you're taking a left to right. Everybody good? All right. So again, these cross over each other and change. So we're going to do the integration from -3 to 0. We're going to do the square root of x plus 3 minus 0 dx. And we're going to do from 0 to +3 of the square root of 3 minus x minus 0. Sorry. When we integrate, we get 2/3 x plus 3 to the 3/2. That's this one. Remember, we make it to the 1/2. And that's going to go from -3 to 0. Then we're going to add this integration. It's going to be -2/3 of 3 minus x. It's negative because our x is in the back and it's being subtracted. So we got to take a -1 derivative as well. To the 3/2 from 0 to 3. And when you plug it in, you get 4 square root of 3. Then it says, let's do it horizontally. I'll stop after this part. It's a good stopping point. There's nothing to write on this page. Just flip it over. I am going to show you this really quick. If we do it horizontally, what do we have to solve for on these? X. So I would do y squared equals 3 minus x. Move your x over and move your y squared. Does everybody understand that? So we would solve it. So when you see these equations in just a second, that's where they come from. So we get the integration from 0 to the square root of 3. Of 3 minus y squared minus y squared minus 3 dy. This is gonna give you the integration from 0 to the square root of 3 of 6 minus 2y squared dy. So that's this put together, so simplified. Remember, the square root of 3 and 0 came from setting those two functions equal together. So if you don't know where those came from, we set those two functions after we solve for x equal to each other to get our two y's. Our integration is going to be 6y minus 2y cubed over 3 from 0 to the square root of 3. And that would give us 4 square root of 3. So right, good. All right. So we'll stop there and we'll pick back up tomorrow with this.